Hello everyone, and welcome to my presentation, X-ray computed tomography studies of moisture content distribution in spruce boards exposed to liquid water. What does this long title mean? Well, what we try to do is we try to replicate the conditions that wood might suffer during construction of a wooden building. For instance, when it rains in a horizontal surface, water might be there for a while in liquid state, which makes us expect the moisture content inside the wood to change. We want to study this changing moisture content inside wood. To do that, we prepare our samples like this. We glue the plexiglass cylinders so that we can fill them with water. Then we arrange them like this so that the specimens on top match the specimens on the bottom. They come from the same board. And then we scan all of them in the center. Then our CT image looks like this. You see that the samples look quite similar, but the one on the top has the outer part of the annular rings exposed to the water, and the one on the bottom has the inner part of the annular rings exposed to the water. If we take the one on top and define our region of interest, what we can do is we can define a layer underneath the surface that in our case is 2.25 millimeters, and measure the moisture content in this layer with our scanner. Then we can move to the next layer and the next layer until we reach the bottom of the sample. In total, we ended up with 18 values of moisture content for one value for each of these layers. How do we interpret these results? Well, we can turn 90 degrees our sample in a way that we have the top part to the left and the bottom part to the right. And now I can play a profile of moisture content that shows us that this piece at time 0 has a quite homogeneous moisture content, but through time, the left part, which corresponds to the top part, to the water exposure, raises quite much, while the bottom one dries because we had quite dry conditions in our lab at the moment of the experiment. Or we can look at how different layers absorb water at different rates. Do you see the layer on top absorbs a lot of water quite quickly, and this rate and this amount of water is reduced as we go down inside of the wood sample. Then we have some questions to answer with this data. Does it have an influence if we expose the inner part or the outer part to the water? I studied that by studying the slope of the trend line of the evolution of moisture content of the second layer in the graph that I just showed you. So you can see it marked in this graph. This slope would tell me something about the rate of absorption. And if I compare, I can see that the outer part absorbs water a little bit faster than the inner part, even though they overlap a little bit. We could also look at the density. Does the density influence the rate of absorption? Well, we couldn't find any relation. We don't see anything that will tell us that there is a correlation between density and the rate of absorption in the parameter that we used. How deep inside the wood does the moisture content reach 18%? We found out that it could be down to 11.25 millimeters that the moisture content is above 18%, which means that when the water goes away and wood starts to dry from the surface, we might think that it's dried, but it's still a region underneath the surface that has a moisture content that is dangerous. How is the behavior of moisture during drying? Well, that's the next step in our project, and I hope you'll hear about it pretty soon. Thank you very much for listening.